This video covers how to deal with pulleys in Newton's second law problems. So let's assume that we have a pulley with two different masses, and we can assume that the larger mass is traveling down, which would cause the smaller mass to travel up. One important thing to note about pulley problems is that the tension force is the same throughout the entire system. So let's draw the free body diagram for mass 1 and 2. We know that both masses have a tension force acting up and weight forces acting down. We also know that since the masses are connected by a rope, that the rope doesn't stretch or compress, that the acceleration of the two masses are going to be equal in magnitude but opposite in direction. So let's apply Newton's second law to the first mass. We know that there's a tension force acting up or in the positive direction and a weight force acting down, and this can be equal to the object's mass multiplied by the object's acceleration. Take note that the acceleration here would be a positive since the object is speeding up while traveling up. Next, we can then apply Newton's second law to the second mass. So we know that there is a tension force acting up in the positive direction and a weight force acting down in the negative direction. We can then set this equal to the mass times the acceleration, and the acceleration here is going to be negative since the object is speeding up while traveling down. So let's simplify this equation a little bit more. By taking the negative sign in the front of the right side of the equation, we can then multiply each side by -1, and we find that the other way to write this Newton's second law for the mass is that W2 minus T is equal to M2 times the acceleration. So there's another way that we can approach pulley problems, and that is to choose a rotation to be positive or negative. This sounds confusing, but bear with me. So let's choose that a clockwise rotation is going to be positive. This means that anything going up on the left is going to be positive and anything going down on the right is going to be positive. So taking these directions into account, we can rewrite Newton's second law equations for the two different masses. So for mass 1, which is on the left, we can see that up is positive, so therefore we will have tension minus weight equal to the mass times the acceleration. And for the second mass, which is on the right, where down is positive, we know that the weight will then be positive and the tension will be negative, and that the acceleration then would also be positive. And as you can see, we ended up developing the same equations with both of these different approaches. So either approach is an acceptable way to tackle these pulley problems. Let's do an example. So here we have a 20 and a 5 kilogram mass that are hung by a pulley. The 20 kilogram mass is accelerating towards the ground, which means the 5 kilogram mass is accelerating up, and we want to know the tension in the rope and the acceleration of the two masses. So let's apply Newton's second law to both of the masses. And our free body diagrams both have tension acting up and weight forces acting down. Now let's apply Newton's second law to mass 1. So we know that it is speeding up on the way down, so it must have a negative acceleration. We can then plug in the masses and the gravity, and we can then solve for the tension force in terms of the acceleration. Next, we can look at the second mass and apply Newton's second law, and we still have two unknowns, but we can place in the value that we calculated for the tension force above, okay? And this way, we can then solve and find that the acceleration is equal to 6 meters per second squared. Next, we must find the tension force. We have two equations and only one unknown, so you can use either to solve for the tension. Let's first use the mass 1 equation. When we plug in the acceleration, we find that the tension is equal to 80 newtons. And just to make sure we're right, let's solve for the tension in our mass 2 equation. All right, and we plug in our known values and we see that the tension is also 80 newtons.